Very good evening, all my dear students. Welcome back again to yours Unacademy NEET English channel. So, how is everyone? So, today we are going to start with fabulous optical isomerism part 2. This is really very important topic. As I've told you in the part number 1 of tautomerism, but let me see that am I audible and visible to each and everyone? I want to see some green signal from the chat section. My dear kids, if I'm properly audible as well as visible to each and everyone, do let me know and show me the green signal. Duration of the session, it's in between 1 to 2 hours, not more than 2 hours, right? Because only that much is left. You know that for 6 hours I have taken part 1 of optical isomerism, so today is optical isomerism part 2, and definitely it is not going to take more than 2 hours. So kids, I will let you know each and everything in detail. Are you ready? I want to see the Josh in the chat section. Do let me know. First of all, that is everyone ready? How's the Josh? I want to see Josh in the chat section, kids. Ready? I can see the fire in the chat section. Yay! Srinath is there, Rinya is there, Santosh is there, Man is there. So each and everyone, all my dear students, we are going to deal with anomers, epimers, and definitely we are going to start with compounds, those who are not having any chiral carbon, but then also they are optically active. This is the real thing. In the lecture number 1, I have told you chiral carbon is not the necessary condition. What is required, that as a compound should be chiral, that compound should not have plane of symmetry and center of symmetry. Kids, so today the time has come that we should deal with those compounds which are not having even single chiral carbon, not a single chiral carbon, but then also they are all optically active. Yes. Oh, yes. Who is having happy birthday? Oh, Srinath, Killer Science, I can see that Srinath is having happy birthday. So, Srinath, wish you a very happy birthday. May Almighty God bless you with all happiness and prosperity. All right. So, let's start, kids. Those who are new to this channel, subscribe this lovely channel, and all my dear students, rest of lovely students, hit the like buttons. Everyone smash the like buttons. I want to see more likes now. Let's start optical isomerism part 2. So see to it, optical isomerism part 2. Everyone, optical isomerism part 2. Part 2. And in this optical isomerism part 2, we are going to start with those compounds, those who are not having any chiral carbon, but then also they are optically active. Now see kids, see the magic. If I say I'm having one compound like this, CH3, H, double bond C, double bond C, CH3, H. One is this compound. And if I write down over here that this compound, GI, it will not show GI, but optically active isomerism. It is optically active, yes. Now let me draw another compound. See to it. CH3, CH, double bond C, double bond C, double bond C, CH3 and H. Now if I say this compound will show GI, answer is yes. Optically active, No. So see, it's, if you see this compound, these two compounds, this will not show GI, but that will show GI. This is optically active, but that is not optically active. Are you able to understand anything? In the starting, you will say, no, sir, we are not able to understand anything. Both of the two compounds, they are looking exactly same. So what's the difference? It's just, if you see these two compounds in 2D, they are looking like both of them are like same. But if we go to see the three-dimensional structure of this compound or the molecular orbital arrangement, then you will come to know why this difference is there in these two compounds. Let me show you this compound. See, this is not the true structure of this compound. Let me tell you. This compound is like this. CH, let us suppose this hydrogen is coming towards your side. This hydrogen is coming towards your side, and this CH3 is going away from you. Now, if I write this carbon, and in between these two carbons, there is one pi bond. Just see how the pi bond is looking like. The pi bond is going vertical. Let us suppose this hydrogen is being horizontal. It is placed horizontal in the plane of paper. This hydrogen is placed horizontally in the plane of paper. This is also horizontally, but this is lying vertical. Then this carbon's pi bond will also located vertically. You see, vertically, and they are forming pi bond. So this is also being vertical. You can say this is also being vertical. Now on one carbon, if one is going perpendicular, then another pi bond definitely that will go horizontally. It is going like this. So this carbon's pi bond also it will go horizontally, right? Now it's sigma bond. These sigma bonds horizontal, and this pi bond, you can see this sigma bond is vertical. If the sigma bond is vertical, suppose sigma bond is horizontal, it is lying in the plane, then pi bond will be vertical. If one pi bond on one carbon is like this, then another pi bond will be like this. So you see this pi bond is going horizontally. It is going horizontally, it is going horizontally. Then it means the sigma bond will go vertical. Sigma bond will go vertical, kids. Sigma bond will go vertical like this. So see, here is hydrogen and there is CH3. Now try to understand. This is very looking like very tough. If I focus only on these bonds, try to understand. If I draw this CH3, this hydrogen and this bond, it's like this. Here is hydrogen, here is being hydrogen, here is being methyl, this is being hydrogen, and here is being methyl. Can you divide this compound in two equal parts? Is it possible? Just try to understand. If you cut it like this, see, if you try to cut it like this half portion will come towards your side and half portion will go that side of the board. Now, this hydrogen's half of the portion will come towards your side and half of the portion will go toward that side. But once if you're coming over here, the methyl is that side of board and hydrogen is this side of the board, you won't be able to divide in two equal parts. But if you try to cut it like this, if you try to cut it like this CH3 half of the portion toward this side, because one hydrogen is coming towards your side, one hydrogen is going that side, and one hydrogen in the plane of board, half of the portion, and hydrogen half of the portion. But once you go that side, you won't be able to divide in two equal parts because you are going like this, upside methyl, downside hydrogen. I think you are not able to understand. Let me tell you the 3D model. Let me show you the 3D model. See, everyone. Try to understand, kids. Let us suppose this green one is hydrogen. Green one is hydrogen. This hydrogen. So this is coming towards your side, and this blue one is methyl. This is going away from you. Can you see? Hydrogen is coming towards your side. Methyl is going away from you. And here the hydrogen is up and methyl is down. Just try to understand. Now you cut it into two equal parts. You see this compound is like this, or this compound is like this. You see this compound is like this. Now try to cut like this, sandwich cut. This half of portion of the green will go up, half blue will go up, half down. But if you come over here while cutting like sandwich cut, if you come over here, upper side green portion is going and downside blue portion is going, no plane of symmetry. And once if you try to cut it like this, like this, now half portion will go that side, half portion will go that side, equal, half portion equal. But once you come over here, you see this side is green portion, that side is blue portion, no plane of symmetry is here. Now you combine it like this, you will be able to understand that this compound is not having plane of symmetry. It is like this. This arrangement is like this. You try to cut it, there is no plane of symmetry. Are you able to understand? See, kids, everyone, do let me know that yes, you got it. Now in the examination, you won't be able to draw this three-dimensional structure. In the examination, you won't be able to draw this three-dimensional structure. Then see the trick. What is the trick is over there? Just try to understand. Let me give you HSP Baba's trick. Everyone see. This is one carbon. This is one carbon. You just try to focus on the terminal carbons. Can you see the hybridization of terminal carbons? This carbon is sp2 hybridized. This carbon is also sp2 hybridized. The middle carbon is sp hybridized because it is attached with 2 pi bonds. Leave this sp hybridized. Just focus on sp2 hybridized carbon and see to it. Here is one atom or group, that atom or group should not be there. That means if this one is R1, this is R2, R1 should not be same as R2. If this one is R1, this should be R2, and R1 should not be equal to R2. Here also, whatever the atom is present, let us suppose this is R1 and this is R2, they should not be same. This R1 should not be same as R2, and it's not compulsory that this should be same or different. They can be same or they can be different, but these two must be different. This R1 should be different with R2. One thing is that R1 should not be equal to R2. R1 should not be R2, and these 2 pi bonds or 4 pi bonds, number of pi bonds must be even. Kids, do remember these number of pi bonds must be even. They should not be odd. These pi bonds must be even, first condition. And second condition, each sp2 hybridized, as I have told you, each sp2 hybridized carbon must be attached with different atoms or groups. Atoms or groups. Are you able to understand, kids? Everyone? Is everyone able to understand? Let me give you examples and let me show you the question. I will give you 4 compounds and do let me know that which compound will not show optical isomerism, which compound is not optically active. You see this compound is not having any chiral carbon, no chiral carbon, but still compound is optically active. No chiral carbon, no chiral carbon, but then also compound is optically active, but then also optically active. Now see, question is, which compound is not optically active? Which compound is not optically active? So compounds are, first compound is Cl, H, C double bond, C double bond, C double bond, C double bond, C, ClH, first compound. Second compound is Br, methyl, C double bond, C double bond, C, CH3, OH. Third compound is CH2 double bond, C double bond, C, CH3, H. And fourth compound is Cl, Br, C double bond, C double bond, C, Br, Cl. Now kids, what's your answer? If you are able to understand, do let me know what's your answer. All these compounds, they are not having any chiral carbon, but 3 are optically active, 1 is being optically inactive. Which compound is optically inactive? Fantastic, killer shines, Priyanka, everyone. This compound is optically inactive. Why this compound is optically inactive? That was optically active compound, optically active. This is being optically active. This is also being optically active, but this is not optically active. Why? Because these 2 hydrogen atoms are same. That means R1 is equal to R2. That's why it is not optically active compounds. Right, kids? You are able to understand? Now, try to understand. This was the first category, and these compounds are known as allenes. What? Allenes. These compounds are known as allenes. Allenes. And they have cumulated system. Cumulated system. These compounds are having cumulated system. Okay. Now, let me tell you spirenes. Just see and focus over here. Just see. What I have shown you, let me divide the compounds because GI and optical isomerism, they are going to give you challenge, geometrical isomer and optically active isomer. Just try to understand, kids. This side I will write the compounds which can show GI, and this side I will say the compounds which are optically active compounds. Now try to understand. Right now I've told you compound like this CH3, CH double bond, C double bond, C double bond, C, CH3 and H. Try to understand, because in the examination you won't be able to visualize only the thing which you can do. You can apply HSP Baba's tricks only to find out the answer. So we should keep all these things in our brain to get full marks. What I'm saying, what I'm going to tell you, kids, try to focus over here. This compound will show GI. This compound will show GI, but it is not optically active. Optically active, it's not. But I will say this compound will not show GI, but this compound is optically active. How to find out? In the examination, how will you find out? Just what you are supposed to do in the examination. See, this is being sp2 hybridized carbon, and this is also being sp2 hybridized, and sp2 hybridized carbon, this is attached with R1 and R2. R1 is not equal to R2. This is, and this side also, R1 is not equal to R2. First thing, R1 should not be equal to R2. If R1 is not equal to R2, then see number of pi bonds. 1, 2, 3, odd number of pi bonds. Odd number of pi bonds. So in the examination, just remember God. Just remember God. GI odd. For GI, to show GI, number of pi bonds must be odd. Then it will show GI. Now, if number of pi bonds are even, see, this is sp2 hybridized carbon, this is sp2 hybridized carbon, and R1 should not be equal to R2. R1 is not equal to R2. If R1 is equal to R2, if R1 is equal to R2, neither it will show GI nor it will show OI. If any compound, whether it is having even number of pi bonds or odd number of pi bonds, but if R1 is equal to R2, that can't show GI as well as OI. So R1 is not equal to R2, and number of pi bonds are even. Number of pi bonds are even. Now see, kids, what I am going to tell you. In place of pi bonds, if you see compound like this, just try to focus. Just try to focus over here, kids. In place of pi bonds, what I have drawn? Number of rings. If number of rings are odd, and R1 is not equal to R2, this is suppose CH3, this is hydrogen, this is CH3, this is hydrogen, it will show GI, but not it is optically active. Optically active, it is not. Now see, if number of rings are even, and if R1 is not equal to R2, this is suppose hydrogen, this is suppose CH3, R1 is not equal to R2, then GI, no, it is not going to show GI. Optically active, yes. So what's the difference in between these two compounds? Here the number of rings are odd, there the number of rings are even. Same thing, kids. Number of rings are odd, number of rings are even. Everyone, is it clear to each and everyone? Do let me know in the chat section that yes sir, these are spiro compounds. What are the types of compounds? Their name is being spiro. I hope this is clear to each and everyone, kids. Do let me know in the chat section. Yes sir, this is clear. Is this clear to each and everyone, kids? Do let me know in the chat section. I want to see. Are you able to understand? Do let me know, kids. Hey, show me the thumbs up if you are able to understand. Otherwise, thumbs down. Okay, now I'm going to tell you biphenyl compound. This question has been asked in 2016, the most important compounds. See, both the two type of compounds, they are not having any chiral carbon, but still they are optically active. Now it's a time to see biphenyls. Ortho substituted biphenyls. Do not have any chiral carbon, do not have any chiral carbon, but then also optically active. Optically active. Now see what type of compound we require, kids. This is really very important. If you ever see compound like this, now this is ortho, this is ortho, this is ortho, this is ortho. Just see, this is right hand side ring, this is left hand side ring. Whatever the group I am going to place here, R1, suppose if I say this is being R1 and this is R2, then R1 should not be equal to R2. R1 should not be equal to R2. If I say this is R3, this is R4, then R3 should not be equal to R4, then this compound will show optical isomerism. This will be optically active. This compound is declared to be optically active. Right now, you are not able to understand anything, but yes, this is optically active compound. Now, question arises, kids. Right now, you have to cram it. I will let you know how to find out what I am going to tell you. This is R1, this is R2, R1, R2, and this is R3, this is R4. What these groups can be? R1, R2, R3, R4 can be any groups, or these R can be groups or atoms. But which atoms? Bigger atoms. Atoms like bromine or iodine. Either to these R should be group, or if they are atom, the atoms should be bigger groups like bromine or iodine. Kids, wow, Srinath, that's really fantastic. Now see, kids, if I say this compound is optically active or not, see, let me draw one compound, kids. This is the question of 2016. If I write down here iodine, bromine, iodine, what will you say? Is this compound optically active or not, kids? Is this compound optically active or not? Then the answer is yes, optically active. Now if I draw a compound like this, if I write down here fluorine, chlorine, bromine, fluorine, what do you think? This compound is optically active. What will you say? Is this compound optically active? No, this compound is not optically active. Not optically active. Now, if I draw a compound like this, see, if I draw a compound like this, if I write here iodine, bromine, Iodine. What will you say? This compound is optically active. Is this compound optically active? Answer is no, not optically active. Now, kids, your brain must have started thinking why this compound is not optically active. What's wrong with this compound? Now, your brain must have started asking number of questions. Sir, please explain why this compound is not optically active. How many of you are in need of to understand why this compound is not optically active? Now, see kids, there is one funda. These groups are at ortho position. All these four must be present at ortho. All four atoms or groups must be present at ortho. Must be present at ortho. Otherwise, this compound is not going to be optically active. How many of you are able to understand? How many of you are ready? Kids, show me in the chat section that yes. No, it's not meta position attacking. It's not with that. I will let you know. How many of you are ready to understand, to visualize it? This is rank deciding question. Now see kids, everyone try to understand it. If I draw one compound like this, just try to focus on this compound. This compound is having plane of symmetry. We can divide this compound in two equal parts from here. This is vertical plane of symmetry. You can see vertical plane of symmetry. Vertical plane of symmetry. This is being the vertical plane of symmetry. Vertical plane of symmetry is present. Or we can cut it like this sandwich. Let me show you. Let me show you in 3D. Just see. These two phenyls, let us suppose these two NCRTs are like phenyls. Just see over here. Can you see? Is it visible? Two NCRTs are visible. Now, I can cut it from in between. See from here. These two are two NCRTs. Let me see how to cut it. Cut it like this. Vertical plane of symmetry. One NCRT, this treat it like phenyl, and one phenyl will go that side and one phenyl will go this side. Can you see? This is vertical plane of symmetry. If I cut it in between like this. Now, I can even cut these two phenyls like this. This is sandwich cut. Upper half and the lower half. They will be same. So, either way I can cut, we will get plane of symmetry. We will get plane of symmetry. Right? Everyone is able to understand? We will get plane of symmetry right now. Just tell me, keep on telling me, yes, you are able to understand. Now, these two phenyls are like this and they are planar, they are in the same plane. But if I attach over here this ortho position, see ortho position. Why I am talking at ortho only? If you place any group over here, para, meta, para, there is no problem. But this place, this place, see my head is going, this place is limited place. If I place NO2 over here, NO2, COH, NO2, COH, then there is no too much space. Now one phenyl ring will bend, it will go vertical. Its NO2 will go up and COH will go down. This NO2 will be over here and COH will be at this place so that they can have space. When no bigger groups were present at this place, then both the phenyl rings were like this. But when these two ortho position of this phenyl and two ortho position of this phenyl are attached with bigger groups, then one phenyl ring will change its plane. It will go vertical and it will remain like this. Now see, this is NO2. Let me put. See, just try to understand. If I say this green one is NO2, this green one is NO2, can you see? Is it possible? Could you see? Now this blue one is COOH. Just try to understand. This is being COH, this is being NO2. Same, please God cooperate. Yeah, till now it's okay. Okay. Now this ring is like this and it's NO2. Let me place NO2 over here. God, what to do? Let me place NO2 and COH. You can think this is being COH. Now try to understand, if the ring is like this, can you see? Is it possible? Ring is like this. Now let me try to put sandwich cut. This green part, half of the portion will go up, half portion down. This blue part, half of the portion up, half down. But once if you're coming over here, the upper part is being this blue marker and the lower part will be green. You won't be able to see the plane of symmetry because this is being different and downward side is being different. Now you will say, let me cut like this. Let me cut like this, like this. If you're going to cut it like this, the half this blue portion of this pen will go towards your side, half toward this side. But once you go over here, that right hand side you will see the green portion and this left hand side you will see the blue portion. And you cannot cut it from here because if you are going to cut vertical plane of symmetry, this is being different and this is being different. And this is possible only when this NO2 are at, or R1, R2 are at ortho position. Because if you are going to place like this, then they are not going to create steric hindrance at this place. They are like that. Both the phenyls will remain like this. Whatever the groups you are going to attach, you can cut it like this. Sandwich cut, half of the portion upside, half of the portion downside. So each and everything will look like same, kids. I've tried my level best to visualize it. I don't know whether you are able to understand it or not. I don't know. So if you are able to understand, visualize it, it's okay. Otherwise, if you're not able to visualize it, let me tell you right now, if you're not able to visualize it, just try to find out. This is horizontal. This is horizontal. They are having two types of plane of symmetry. This vertical plane of symmetry as well as sandwich plane of symmetry. Sandwich plane of symmetry is present. Now, if you place at ortho position, if you place four groups at ortho position, see how they will look like. One ring will look like this. Another ring will look like this. See, this is one ring. Another ring will look like this. One ring, NO2 is going like this and COH is going like this. Another rings, NO2 will be like this. One NO2 is coming towards your side. One NO2 is coming towards your side. COH is going away from you. Let us suppose this phenyl ring is horizontal and this phenyl ring is being vertical. So, see, if this is being vertical, it will look like this. If this is being vertical, it will look like this. This is its plane, and if that is being horizontal, that will look like this. This is its plane. So these two phenyl rings are being in different plane. This is being vertical, that is being horizontal. Kids, are you able to understand? One phenyl ring is being vertical and one is being horizontal. This is being vertical, this is being horizontal. Two phenyl rings are in different plane. Two phenyl rings are in different plane. Are in different plane. And that's why there is no plane of symmetry. No plane of symmetry. And no plane of symmetry, that means compound is optically active. Is there anyone who is able to understand, kids? Do let me know in the chat section that yes, are you able to understand? If you're not able to understand anything, just remember these R1 and R2 should be different. R1 and R2 should be different and they must be located at ortho. That compound is going to be optically active. Everyone, that's really fantastic. Fantastic. Wow, that's great. Now, after this, I'm going to tell you, I'm going to explain epimers, the most required topic, most wanted topic, epimers. Is everyone ready? This epimer is not only important in your organic chemistry, this is also going to play really very important role in your biology also. That's why this is going to hold a hell lot of weightage. Ready everyone? Now see, what are epimers? Epimers are those diastereomers which are having different orientation of one hydroxyl group. One hydroxyl group. So what is the difference? Difference of just one hydroxyl group. Space orientation of only one hydroxyl group. Then we will say they are being epimers. Now how to understand? How to understand it? Just see, just focus over here. If I draw three compounds, just try to understand, kids. Three compounds I am going to draw. 1, 2, 3. These three compounds will change your life. Definitely will change your life. And these are your favorite compounds. Favorite compounds. C double bond O, CH2OH, CH double bond O, CH2OH, CH double bond O, CH2OH. Till now, is there any difference? Till now, is there any difference in between A, B and C? Is there any difference? No difference. All three are looking same. All three are looking same. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Now A, B and C. Is there any difference? All three are looking same. No difference is there. Till now, no difference is there, kids. Now if I say CHOH, CH, OH, CH, OH. Is there any difference? Till now, is there any difference in between three compounds? Is there any difference? No difference. Now see, CH, OH, CH, OH, CH, OH. Now kids, do let me know, is there any difference in between three compounds? First carbon, second carbon, third carbon, fourth carbon, fifth carbon, sixth carbon, first carbon, second carbon, third carbon, fourth carbon, fifth carbon, sixth carbon. First carbon, second carbon, third carbon, fourth carbon, fifth carbon, sixth carbon. Is there any difference till now? No difference is there, kids. Till now, there is no difference. Just focus. Just better to keep your eagle eyes on these structures. Once if you are getting difference, do let me know where is the difference. You got any difference, kids? Do let me know. Now, if I place CH, OH, CH, OH. Now here CH, OH, CH, OH. In between compound 1 and 2, is there any difference? In between compound 1 and 2, is there any difference? In between compound 1 and 2, A and B, is there any difference? A and B, is there any difference? Yes, the difference is over here. If you are able to understand, the difference is at second carbon, OH is on the right hand side, and at second carbon, the OH is being on the left hand side. This is being the difference. So there is difference in between these two. So what will you say? This compound's name is glucose. This compound's name is glucose. Kids, this is your glucose. And that compound's name is mannose. Mannose. And that compound's name is, let me draw, then I will write down the name. This is glucose, this is mannose. They are having difference at one carbon. The orientation, in the orientation of OH, the space arrangement of OH differing at one carbon, that is being second carbon. So these two are, yes, what relationship they are going to hold? They are apimers. They are apimers. Now kids, are they mirror images of each other? Are they mirror images of each other? No, they are not mirror images. So they are also distereomers. Distereomers. They are also distereomers. So apimers are always distereomers. Now see, this compound, if I place HOH and HOH, now just let me tell you, the name of this compound is being galactose. 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 Now, is there any difference in between A and C? A and C. A and C. So if you see, in between A and C, there is difference. In C, the fourth carbon OH is being this OH. This OH is on left hand side. This OH is being on left hand side, and here the OH is being on right hand side. So this is the difference. So A and C, that means glucose and galactose are also apimers. So let me write down, A and C are also apimers. But kids, if I say B and C are apimers, what do you say? B and C are apimers. B and C, no, not at all, because B and C, they are differing at two carbons. See, its OH is over here. Its OH at this position, you can see this OH, this OH over here, that OH, This is one difference. This OH is on right hand side, this is on left hand side. They are differing at 2 carbons, so they are not apimers, they are diisomers because they are not mirror images, so they are differing at 2 positions. So B and C are not diisomer, B and C are not apimers, B and C are just B and C are diisomers, Now, this thing is okay. This thing is clear to all of you. Now, how many of you are always getting confused which one is mannose and which one is galactose? How many of you are getting confused always in between the structure of mannose and galactose? If yes, do let me know. I will tell you the trick for it, mannose and galactose. If you are getting confused in between mannose and galactose, do let me know. I will give you the trick. Just write down, yes, me. I'm waiting for answer. Then only I'm going to give you the trick, kids. Write down, yes. Aspiring medico is writing yes. Now see, kids. It's everyone's third carbon OH is over here. Just see at the top. Third is always OH on left hand side only. At the top of third, it is differing. This is mannose, and the bottom differing, it is galactose. Just see nose. This is nose, and these are toes. Which one is up? Nose is up or toes is up? Kids, do let me know. Nose is up and toes are down. So nose is always up. Nose is always up. Just see, this is nose. Upper carbon different. This is going to be nose. Lower carbon different. This is going to be toes. Are you able to understand? Nose and toes. Mannose, upper carbon different, toes. Galactose, toes differing. So mannose and galactose. If you like it, then do let me know. Yes, sir. Show me some hearts if you're liking it, kids. If you're liking it, show me some hearts, green hearts, blue hearts, whatever the hearts. Liking hearts. Kids, always respond. Your energy is going to give me energy. To every action there is equal and opposite reaction. Newton's third law of motion. Kids, do remember, don't forget to show your energy. So nose and toes. Now, one more thing, anomers. Apimers is okay. You are comfortable with apimers. Now, anomers. And after anomers, you must be thinking, sir, I'm always confused. All anomers are like apimers, all apimers, diisomers. What is this blah, blah, blah? We are always confused. I will give you the trick of that also. See, kids, I will give you the trick of that also. But before that, let me tell you anomers. 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 Anomers are those special apimers. See, kids, anomers are those special apimers which differ in orientation of hydroxyl group at carbon which is involved in ring formation, which is involved in ring formation, which is involved in ring formation. What type of ring? Hemiacetal or hemiketal ring. Hemiacetal or hemiketal ring. Hemiacetal or hemiketal ring. So this is the definition of anomers. So from the definition, it is getting very much clear that all anomers are always epimers. From this definition, at this point is getting clear that all anomers are always epimers. Is this point getting clear or not? All anomers are always epimers, but reverse is not true. Now see kids, let me give you one example. If you see this compound kids, just try to focus what compound is this and try to let me know. CH double bond O, CH2OH, 1, 2, 3, 4. HOH. If I say 1 carbon, 2 carbon, 3rd carbon, 4th carbon, 5th carbon, 6th carbon. If 5th carbon and 6th carbon, they are last and second last carbon, and last and second last carbons OH are on same side. What do you say? Last and second last carbons OH are on same side. What do you say? Do let me know. Capital D configuration. This is capital D configuration. Capital D. Okay. And if I write down this compound is like this: H, OH, 3rd carbon OH this side, H, OH. This compound is glucose. So D positive. This positive sign is indicating that in nature it is dextrorotatory, and this compound's name is glucose. Kids, let me tell you, these two OH are on same side. Last and second last carbon, last and second last carbon OH same side, carbons OH same side. That's why we said this is being capital D, and this positive side is indicating in nature it is dextro. In nature it is dextrorotatory. That's why plus sign, and this is being glucose. You can see very clearly. Now you know very well this compound is sp2 hybridized. So, and this oxygen is being delta negative, this carbon is being delta positive. So this 5th carbon's O negative will try to form bond from the right hand side, as well as bond from the left hand side. From both the side, this O negative will attack. Why only this O negative? Because this is going to form a 6-membered ring. This O is already of 5th carbon. But along with 5th, this is also going to attack on 1st carbon. Along with 5th carbon, this is also going to be the friend of 1st carbon. Just try to understand. And this is going to attack from both the side, because sp2 hybridized means planar. Planar means one pure p orbital lying above the plane and below the plane. So it will attack from both the side. And once it is going to attack from both the side, just try to see what it is going to form. What is going to form? See kids, everyone. 1, 2, 3, 4. Just see. CH, this O negative will go over here, and this fifth carbon oxygen has formed a bond from this side. Just focus on oxygen. Oxygen is acting as a bridge. 1, 2, 3, 4. Oh, 1, 2. I think one carbon is missing. 1, 2, 3. Okay, it should be over here. This oxygen must be over here, because this is being fifth carbon. 1, 2, 3, 4, 5. So this carbon and this oxygen, first carbon's O is over here. And where is the bond formation? New bond formation has taken place in between first carbon and this fifth carbon. Focus over here. And this is OH. And just third carbon's OH is lying over here. The third carbon OH and first carbon OH, they are on opposite side. Just see which carbon OH? First carbon OH and third carbon OH, they are being opposite side. And one more compound we will get. We are going to get one more compound, C. In this CHOH, first carbon, second carbon, third carbon, fourth carbon, fifth carbon, and fifth carbon's oxygen, this is going to form bond from this side. So this OH will come on this side. This OH will come towards this side, OH. And you see 1, 2, 3, third carbon OH is also on this side. So they are being on same side. You can see clearly this OH and this OH, they are on same side. So is there any difference? Is there any difference in between first compound and second compound? Let me form the ring. The ring is like this. Is there any difference? These two OH are on same side. These two OH are on different side. 1, 2, 3, 4, 5, and 6th. Rest of the atoms I will complete later on, but see the difference when first and third carbon OH are on different side. Always remember this is going to be alpha. Already it was D, positive glucose. And when 1 and 3 OH are on same side, we will say beta. D was already positive glucose. Now let me complete rest of other atoms. Rest of other atoms, H, OH, H, OH, H, CH2, OH, CH, OH, CH, OH, CH, CH2, OH. Now kids, this is the open chain structure of glucose. When open chain structure of glucose is added to water, when it is added to water, there is ionic equilibrium. You can say equilibria is maintained, and in between these two compounds, equilibrium is maintained. See kids, when you place it inside water, this open chain structure will change into closed chain structure. This open chain structure will change into this closed chain structure. That means all three structures are lying in equilibrium. All three structures, they are lying in equilibrium, kids. Now, What is the difference in between these two structures? If I say what is the difference in between these two structures, they are just differing on first carbon. This first carbon OH is on right hand side and this carbon's OH is on left hand side. This is the only difference. So only difference in one OH, difference in only the orientation of one OH, they are going to be epimers. So this compound and this compound, these two compounds, what's the relationship they are holding? They are being epimers. And why they are being special epimers? They are being special epimers because when it is in open chain structure, no, it is not chiral carbon, but in closed chain structure. See how many chiral carbons are over here. In this compound, we are having 1 chiral carbon, 2 chiral carbon, 3 chiral carbon, and 4 chiral carbon. But in this compound, this is also going to be chiral carbon. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is closed chain structure. Both of these are closed chain structure, hemiacetal pyranose ring structure, and they are differing only in the position of OH. So these OH are involved in the unstable ring formation, and that's why they are known as anomers. They are known as anomers. And this conversion of, because this alpha D glucose is continuously converting into beta D glucose and beta D glucose is continuously converting into alpha D glucose through open chain structure. So alpha D glucose and beta D glucose conversion, interconversion into each other is known as mutarotation. This is known as mutarotation. I hope kids, everyone is able to understand. So alpha D and beta D are hemiacetal pyranose ring structure. Kids, is it clear to all of you? Is it clear to each and everyone? Do let me know that you are able to understand it. Now same thing, if I tell you in fructose, if I tell you the same thing in fructose, just see to it. CH2OH, CH2OH, C double bond O, CHOH, 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 and CH2OH. Just try to understand the same fifth carbon, 1, 2, 3, 4, 5, 6. This is going to develop negative charge. And now the oxygen is at fifth carbon, but this will attack on second carbon's carbonyl carbon. This is being delta positive, this is being delta negative. This will attack from the right hand side as well as this is going to attack from the left hand side. From both the side it is going to attack. You can see clearly above the plane and below the plane. This oxygen negative will react with this H. So this is being the open chain structure, and this is going to give you two structures. Just see to it. What are these two structures? Everyone try to focus on. Now second carbon and fifth carbon. Let me 1, 2, 3, 4 carbon. See, 1 carbon, 2 carbon, 3 carbon, 4 carbon. Try to understand. 4 carbon. It's all in between 4 carbon, and this is being oxygen. You can see it's oxygen, H is over here, and this oxygen is going to form bond over here. You can see this is going to be your second carbon, third carbon, fourth carbon, fifth carbon. Now first and last carbon, let me draw. This is CH2OH, this is your sixth carbon, and this is CH2OH. This is your first carbon. You can see first carbon. And third carbon, this is your third carbon OH. So what we can see, the second carbon OH and third carbon OH are on opposite side. In glucose, first and third, when they were on opposite side, we said alpha. Here second and third carbon OH are opposite. Alpha D, in nature it is found as levorotatory fructose. Now another structure, let me draw. This is being second carbon, third carbon, fourth carbon, fifth carbon. What I am going to tell you now, this oxygen has formed in between the second, third, fourth and fifth. Now let me write down. This time the CH2OH was here, this time CH2OH over here, and this OH over here, and the third carbon OH at this place. Now these two OH are on same side. What I am going to say is second and third carbon OH same side. I will write beta D fructose. Beta D fructose. Let me complete it. Rest of the atoms. This is first carbon, second carbon, third carbon OH, H, OH, H. Now CH2OH. In this compound also, third, this is being H, OH, H. Now you can see this is being beta D fructose. At how many points these two compounds are differing? Do let me know. At how many points these compounds are differing? This is the aqueous solution. You can see this is being the aqueous solution. That open chain structure of fructose is changing into ring, and ring is of 1, 2, 3, 4 and 5th atom. So it is looking like furanose. How the furanose will look like? Please see, this is being furan. You can see furan. This is being furan. 4 carbon atom and 5th is oxygen heterocyclic. So this is hemiketal furanose ring structure. So you can see these two compounds are differing only at second carbon. Second carbon OH is on right hand side. Here second carbon's OH is on left hand side. So these are special type of apimers known as anomers, and their anomeric carbon is second. Anomeric carbon is second carbon. Anomeric carbon is being second carbon. It's really holds a whole lot of weightage because it's not only in chemistry, it is equally important in your biology also. So two portions you are going to cover at the single place. Kids, do let me know that yes, each and everything is getting cleared in your mind. You're getting it. Kids, do let me know. I want to see. Yes, everyone is able to. Akanksha Singh, Priyanka, that's really awesome. Sundaram is there. Sun Muga Sundaram. Kids, now see. Once these things are clear in your brain, now I'm going to give you the one best option so that your all the doubts will get cleared. See, try to understand, kids. Try to understand. If in this circle, if I write down anomer, and if I draw another circle, and in this circle, if I write down epimer, and if I draw another circle, and if I write down over here diastereomer, now if I draw another circle, and if I write down over here configurational isomers, configurational isomers. And now finally, if I draw one more circle and if I write down over here isomer, isomer. Now kids, try to understand. Everyone try to understand what I'm going to tell you. All anomers are always, all anomers are always epimers. All anomers are always epimers. All epimers are always diastereomers. All anomers are always diastereomers. But all epimers need not to be anomers. All anomers are always epimer. All epimers are always diastereomers. All anomers are always diastereomer, but reverse is not true. All anomers are always, all anomers, all anomers all anomers are always configurational isomers. All epimers are always configurational isomers. All diastereomers are always configurational isomer. But all configurational isomers need not to be like this. Now see, all anomers are always isomers. All epimers are always isomers. All diastereomers are always isomer. All configurational isomers are always isomers. But all isomers need not to be all this. Gets, this is the most confusing point, but I hope that you are able to understand that. Anomer, epimer, just try to think, correlate. If you're not able to understand, everyone try to correlate. All anomers are always epimers. All anomers, epimers are always diastereomers. They are configurational isomers. They are isomers. Now see, what I am going to tell you, what I am just trying to tell you, kids, all anomers are always epimers, all anomers are always diastereomers, all anomers are always configurational isomers, all anomers are always isomers. Now, all epimers are always diastereomers, all epimers are always configurational isomers, all epimers are always isomers, but reverse is not true, kids. Just try to follow this funda. You will never get negative marks. AEDCI. AEDCI. A. AEDCI. Just remember this point. AEDCI. Kids, are you able to understand or not? Do let me know. Got it? Everyone got it? Now, do let me know that I have told you DNL configuration or not. I have explained DNL configuration. Alcohol ether, I will let you know. Satish Kumarji, definitely I will let you know. First of all, do let me know capital D and capital L configuration I have told you or not. Trio, right? Trio I have told you or not. Do let me know, everyone. Yeah, it's a mind map, and definitely if you are able to understand, really I'm feeling good. Now kids, do let me know capital D and capital L configuration I have told you or not. Trio, right? Trio configuration I have told you or not. Do let me know, so that if not, then I can explain it. Hurry up fast. I want to see in the chat section whether I've told you or not. Hey kids, can you hear me? Not. Okay, Priyanka. Now see, let me tell you. Let me tell you. So, types of configurations. This is going to be the last topic. It's types of configurations. This first one I have told you. I know very well that the first one I have told you. 1, 2, 3, 4. Now see, the first one was R and S configuration. This I have told you. It was an absolute configuration. Absolute. This I have told you in detail. Now, capital D and capital L, this I have to tell you, this is relative configuration. Trio and erythrio. Trio and erythrio, this I have to tell you. And small d and small l, this is an experimentally determined, so no need to tell you. It is experimentally determined, kids. Now, everyone is ready? Is everyone ready to understand capital D and capital L configuration? Is everyone ready? Now see, capital D and capital L configuration is important. Capital D and capital L configuration, this is important in carbohydrate chemistry as well as it is important in amino acids. At two places, this plays important role: carbohydrate chemistry and amino acid. But before I proceed, let me tell you one point very clear, that capital D and capital L has nothing to do with small d and small l. They are totally different. Small d, small l, they are different, and these are different. Let's see. Just try to focus what I am going to tell you, kids. If I draw one line and this line, the plus sign, just try to focus. This is your Fisher projection formula. Fisher projection formula. How and what Fisher said? Topmost group, the highest priority group must lie at the top. This is according to Fisher projection formula, kids. Fisher projection. What Fisher said, the topmost priority group should lie at the top. Now, if I write H, OH and CH2OH, just try to focus over here. This is being your chiral carbon. This is being your chiral carbon. 1, 2, 3. This is being the IUPAC, and this is being the vertical line. Vertical line, according to Fisher, this vertical line should be your parent chain. This vertical line should be parent chain. What Fisher said? Fisher said, according to Fisher, vertical line must be the parent chain. Must be the parent chain. Vertical line must be the parent chain. Now see, if I tell you this OH and this OH, both the OH are on same side. Both the OH are on same side, you see. And that's why when both the OH are on same side, both OH are on same side, we will say it is D compound. Its name is glyceraldehyde. So we'll say D glyceraldehyde. Now how the L glyceraldehyde will look like? See kids, this H, this OH, this CH double bond O, and this CH2OH. This OH is on right hand side and that OH is on left hand side. They are on different sides. So we will say this compound is L-glyceraldehyde. Are you able to understand, kids? Everyone is able to understand. Is everyone able to understand, kids? Okay. Now see, kids, if examiner is going to give you question like this, suppose examiner has given you question like this. See everyone. CH2OH, CHO, OH and H. Now what will you say? This is D or L? Is this compound D or L? Is this compound D or L? Is this compound having configuration D or L? This is a question. Find out the configuration of the compound D or L. No answer. D. Some are writing small d. Don't write small d. Simple molecular formula of glyceraldehyde. This is simple molecular formula. See, kids, one kid is asking. So CH2OH, CHOH, CHO. This is simple glyceraldehyde, kids. One kid has asked. Simple condensed formula. This is glyceraldehyde. So some are writing L configuration, some are writing D configuration. See, Priyanka, Akanksha is going for L, Shiv Kumar is going for D. Kids, this is the confusion. See, is this compound written like Fisher? According to Fisher projection formula, is it written like? Not according to Fisher. Not according to Fisher. This is the most important point, kids. It's not written according to Fisher. So try to convert it to Fisher. Now see how to convert. I must have told you that day. Draw sign like this. I have told you on that day, hold any one group. Hold any one group and rotate other three. This thing I have told you, not, kids. Hold any one group. Hold any one and rotate other three. Configuration will not change. Configuration will not change. This thing I have told you, not, kids. Do you know this thing? Now CH2OH is on hold. CH2OH is in a hold. Now according to Fisher, this CHO should be at the top. So I have rotated it anti-clockwise. If I am going to rotate it anti-clockwise, this CHO will come over here. And in anti-clockwise direction, OH will come over here. And this position is already locked, so this H will come over here. Now this compound is according to Fisher. This compound is written according to Fisher. Now you can see very clearly that this OH is on left hand side and this OH is on right hand side. So this is L-glyceraldehyde. Are you able to understand, kids? Everyone got it or not? I think this is the first time you are going to understand that this is the way how the compound. You must have always seen that glyceraldehyde. Whenever you have seen glyceraldehyde, you must have seen glyceraldehyde is always written like this. Glyceraldehyde is always written like this in your bio or whatever the chemistry. Whenever you see glyceraldehyde, it's always written like this. Or if you say glucose, glucose you must have seen always written like this, kids. 1, 2, 3, 4. Glucose you must have seen always written like this, kids. CH double bond O, CH OH, CH OH, CH OH, CH OH, CH2 OH, and that's why this glucose, because see, last and second last OH, they are on same side. That's why this is D glucose. D, this D means that they are on same side, last and second last. What do you mean by last and second last? One, this is always at the top. You must have seen at the top. And the parent chain is always vertical line. This parent chain should always this vertical line. This vertical line is the parent chain. This is your green one is the parent chain. Always 1, 2, 3, 4, 5, 6. Always you must have seen the glucose is always written like this only. Kids, are you able to understand? Now let's see in amino acids. Capital D and capital L configuration in amino acids. D and L configuration in amino acids. So all amino acids are optically active. Is this statement right or wrong? All amino acids are optically active. Is this statement true or false? Is this statement true or false? So I would like to say except glycine. Now this statement is absolutely true because they have the formula NH2 CHR COOH. Now if this R is not hydrogen, then this carbon is going to be chiral. Only one chiral carbon, so the compound is always going to be optically active in glycine, and glycine R is equal to hydrogen, and that's why it is optically inactive. One thing is clear to all of you. Is this thing clear to all of you? Yes. Now see, always remember one point in amino acids. In amino acids, if COOH is coming at second carbon, at second position, according to CIP rule, then always remember for R configuration it will be D, and for S configuration it will be L. Now RS configuration you know very well. This I have told you in detail. RS configuration you know. So what is the trick for this? RDSL, red Salman or red, whatever you can say, whatever the trick you can apply. SL, R and D, SL. Okay, now see special, R&D special, you can say. Now let me give you one compound. If this is the compound provided to you, just see and focus on compound. COOH, NH2, H, CH3. Now the question is, what is the configuration of this compound? Question is, find out the configuration of this compound. Find out, everyone. I'm waiting for your answer, kids. Find out the configuration of this compound. Now how to do it? Just apply CIP rule. You know this is being chiral carbon. This is your chiral carbon. Very well, you know. Now according to CIP, this is nitrogen, this is carbon, this is carbon, this is hydrogen. This will be the fourth position, and this carbon, this nitrogen. Nitrogen is having atomic number 7, carbon is having atomic number 6, and this is also 6. Now, who's having maximum atomic number? Definitely this nitrogen will get number 1. And this second atom is oxygen, second atom is hydrogen. So its atomic number is 6, winner. So this is going to get second position, and this is going to get third position. And this is your least priority group. Now, when we move arrow, the arrow will move 1 to 2 like which direction? This is your clockwise direction, and LPG is on vertical line. So V arrow is going clockwise. VC, just complete VC. What should I write? VC, very clear what? Road, very clear road. The code for this was very clear road, very clear road. Now R configuration, you see this compound is having R configuration, and what I have told you, according to CIP rule, this is on second position. For R, we will write this is following D configuration. So the answer is, this is D amino acid, D amino acid. I hope this is clear to all of you. This is clear, crystal clear to each and everyone. This Killer Science has made this with the help of each and every student. Now kids, this is clear. So in amino acid, I have told you DNL configuration, as well as in carbohydrates, I have told you DNL configuration. Now kids, trio and erythrio, this is going to be the last one, trio and erythrio. So I think everyone is ready for this, trio and erythrio. Trio and erythrio. In 20 years, only once it has been asked, trio and erythrio, and that's why I think you don't know what is trio and erythrio. Just see trio and erythrio configuration. Now for some time I will not say anything. I will try to let you know with the help of one diagram. Just try to focus. Just try to focus what I'm trying to tell you, kids. With the name trio, this name I have written trio. Just try to understand what I'm trying to tell you. Trio. This name I have written trio. And this name I have written Erythrio. 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 Could you please let me know? BR opposite. So bulky group opposite, as the name is speaking, trio, 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 trio. Same groups opposite side, same atoms opposite side, same atoms same side, same atoms same side. Same atoms opposite side. So this is all about today's lecture, kids. Now let's solve some questions. I will give you 5 questions and let's try to solve these questions, and these questions will be based on today's topic only. Whatever I taught you, let's do 5 questions. Everyone is ready? Kids, do let me know. Is everyone ready, kids? Yes, kids. How to name this compound, sir, irrespective of configuration? No need to write down the configuration. This is just trio and erythrio, nothing else. Trio and erythrio. Okay. Now see. Question number 1 in front of you. Which compound is optically active? Which compound is optically active? A is B is C is D is Do let me know. What's your answer? What's your answer, kids? Everyone, I'm waiting for your answer. Fast, quick. B. So 3 students are going for B and 2 are going for D. Kids, everyone is failed. Frankly speaking, personally speaking, everyone got failed. See, everyone got failed. See, kids, this is HCH3. Nothing is written over there. That means this is CH3. This CH3 and this CH3, R1 is equal to R2. So it's not, it will neither show GI nor it will show optical isomerism, neither GI nor optically active. R1 is equal to R2. Now you're going for D. 1, 2, 3. Which compound is optically active? Number of pi bonds are odd. So it will show GI. It will not show optical activity isomers. Not optically active. Now see, this compound is chiral carbon. This is being chiral carbon. You can see this is only one chiral carbon. This I've told you when I was telling you optical isomer in part 1. Only one chiral carbon. So this is going to be optically active. Kids. Oh my God, some are saying A. Kids, you have gone for A option. You have gone for B option. You have gone for D option. You have gone for all the options. But all the 3 are wrong. No one has gone for C option. Only the C one is absolutely correct. Kids, everyone got failed. Agreed or not? Agreed or not? Agreed or not? Those who are agreed, show me the thumbs up. Kids, if you are agreed, show me the thumbs up that yes, sir, really we got failed. Really we got failed. Now, another question. See how good questions I'm making. These are new questions. These are new questions which I'm making, kids. Which compound is optically inactive? Which compound is optically inactive? Just see. A. B. C. D. What's your answer? I want to see your answer, kids. This time, definitely you are going to give me the correct answer. Wow, Janvi, I can see your answer, but I don't know whether it is right or wrong. Let me wait for others. Let me wait for others whether your answer is being right or wrong. Akanksha Singh, D. So this time, everyone's answer is correct. this compound will neither show GI nor optical isomerism. So definitely. Now gets another question. This question you everyone got passed. Our next question is, which compound will show GI as well as optical isomerism? GI as well as optical isomerism. So A is B is C is D is So what's your answer? Take care, take precaution, and then give me the answer. I'm waiting for your answer, kids. Everyone's answer. Priyanka is going for C. Let me check it out. What about others? What about others kids? Akanksha is also going for C. So absolutely your answer is being C. This double bond is dead. Cannot show GI. This double bond is dead. Cannot show GI. The first carbon is having two chiral carbon atoms, so they are optically active. These two chiral carbon, this is one chiral carbon. This compounds, this double bond is being dead, but this is being active, so it will show GI, and this is being chiral carbon. So this is the answer. This will neither show GI nor optical isomerism. Nothing it is going to show. Kids, this time really you have proved that yes, you are able to understand. Now kids, another question. Well done, stupendous performance kids by you. Now question is, which is optically active? A, B, C. D. What's your answer, kids? I want to see your answer. Let me check it out. What answer you are going to give? Oh my God. Karthik Kumar, Akanksha Singh, Ravina, Vidhanjanani. Everyone's answer is absolutely correct. Absolutely correct. Absolutely correct. Absolutely correct. Now, kids, the awesome question I'm going to give you, really fantastic question. Just see. This is $1,000,000 question. Very, very important question. Rank deciding question. Question is, find out total number of configurational isomers. So kids, whenever anyone is asking for configurational isomer, when anyone is asking for configurational isomers, do remember configurational isomer means GI plus optical isomers. GI plus optical isomers. To find out total number of configurational isomers for cyclopentane 1,2-diol. This is your compound. If you don't know the IUPAC, you won't be able to do it. And if you know the IUPAC, then options, let me tell you. Options are option number A, 6, option number B, 5, option number C, 4, option number D, 3. Just apply your brain. This question has been asked in AIMS. Yeah, rank deciding question. This question is being rank deciding question. Now, rank deciding question, no one is going to leave, but they are going to get negative marks. No one is going to leave because the questions, they seem to be really very simple. So let's see what answer you are going to get, kids. I'm waiting for your answer. D. Akanksha is going for D. No, it's not Akanksha, it's Akshada. Akshada is going for D. Let me check it out. What others are going for? Fast. So the correct answer, I want to see in the chat section, kids. Hey, everyone, do let me know. 5. Aspiring medico is going for 5. Shiv Kumar is going for D. So the correct answer is being D. I don't know how you did it, but your answer is right, kids. Your answer is right. Now let me tell you. See, if you draw cyclopentane diol, now see, everyone, if I say this is H, this is OH, this is OH, this is H, this is the possibility. Another possibility could be like this: OH, OH, H, H, right? Or the possibility could be like this, and let me write down. This possibility could be like this. This is the compound which is having two chiral carbon atoms, and if I draw its mirror image, H, OH, OH, H, and the third possibility could be like this: OH, OH, H, H. Now see compounds. First of all, let me know this cyclopentane 1,2-diol is going to show GI or optical isomerism. What type of isomerism this compound will show? This compound will show geometrical isomerism or optical isomerism, or both, or none. No book is good. Arab lifestyle, no book is good. All they are having number of misprintings, and all of them got outdated. So it's better to follow my notes, kids. I will provide each and everything whatever is required for the best rank, right, kids? Now definitely this compound, if we see, your answer is absolutely correct. What I can see, and Jyoti, your answer is absolutely correct. This compound will show both type of isomerism. If we see with the eye of, if we see this compound with an eye of geometrical isomerism, then I will say this compound is trans. This compound is trans. And if the same compound, if I see with the eye of optical isomerism, if I see this compound with the eye of optical isomerism, I will say this compound will be either DD or LL, that is RR or SS. So this compound is optically active. This compound is optically active because this is not having plane of symmetry. Optically active because this is not having plane of symmetry. Plane of symmetry is missing. So whatever you can say. So if you say this compound is dextrorotative, then that its mirror image, and both of them are enantiomers. So I will say enantiomeric pair. Enantiomeric pair. And this compound, if you see with the eye of, geometrical isomerism, you will say this compound is being cis. And if you see with the eye of optical isomerism, you will say this is meso, and mirror image of meso is always meso. So the compound is only one. So these are total 3 isomers. Question practice, Arab lifestyle. Once the syllabus is completed, and once whatever the questions I am telling you on the board, just practice from here. Once all the things, if you have completed from here, now once the syllabus of organic chemistry is completed, you can do any book which is having previous year questions, just previous year question, nothing else, no other questions, previous year questions. Whether you can do questions of IIT or medical, but just do previous year questions. Before that, you try to solve these questions, whatever the questions I am going to give you, kids. Everyone is able to understand. So this is the compound. So I can say simply this is trans. So I can write down trans, DD, DL and DL, meso, cis is meso. So these are the 3 total compounds. Now see, if are you able to understand? Have you got it? Have you got it, everyone? Now another question. Find out configurational isomers. I think this is going to be the last question. Configurational isomers. Compound is, this is your compound, CH3, CH, double bond CH, CH, Br, CH, Cl, COOH. So options are, option A is 2, option B is 4, option C is 6, option D is 8. Do let me know what's the answer. Everyone, do let me know what's the answer. Configurational. Configurational. Configurational isomers means Gi plus OI, optical isomers. Four. One answer is coming 4, one is coming 8. See the difference between 8 and 4. Lot of difference. 4. Priyanka is going for 4. Akanksha is going for D. So some are going for 4, some are going for D. 8. B. 4. Oh my god, there is tie between B and D. Now let me tell you kids, what should be the answer? See, this is active double bond. So with respect to Gi, the value of N is 1 and these two are chiral carbons. So with respect to optical isomerism, the value of N is equal to 2. So whenever we are going to find out configurational isomers, that is the value of 2 raised to power N, and this N is equal to Gi plus OI. So for Gi1, OI2, the value is coming to be 3. So 2 raised to power 3, that is being 8. Now kids, half of the percent, 50% students got passed, 50% student got failed. Let me tell you, this is with the formula. If without formula you do this question, how to do it? See kids, without formula. Because formula is not going to visualize anything. So without formula, how to do this question? See, this compound is having 2 chiral carbons and this is active for double bond. I can say if this double bond is cis, then when this is cis, what they can be possible? They can be D and D. This is possible. With cis, what they can be possible? They can be LL. With cis, this carbon can be dextrorotative and that can be levorotative, or that with cis, this carbon can be levo and that can be dextro. So there is, with cis, these 4 possibilities are there. What I'm saying, when I'm taking it to be cis, these 4 possibilities are possible. Now, if I say this is being trans, it is trans also possible. With trans also 4 possibility. Trans DD, trans LL, trans DL, trans LD. So how many compounds all total you are having? Kids, do let me know. Just add these compounds. These are total 8 compounds. So these 8 are possible, kids. I hope that everyone is able to understand each and everything. Either you go with the formula or you can apply simple concept, you will always be able to find out the answer. Now, one question for your homework. One question, last question for your homework, and I will see that answer in the comment section, right? So, last question for your homework. Which compound will show GI? So these are the four compounds, and your question is, out of these four compounds, which will show GI? And that's S for homework. Not right now. DNL experimentally determined. Yes, Abhilasha, for the previous question, if you want to say, if you don't want to go with DNL, you can do one thing, because we cannot find out, but you can go like this: RR, SS, RS, SR. I'm not saying DD is for RR. Either way you can go. You can go like this, or you can go like this also. See, when I'm not going for RR, I can go for SS, then this will be RR, then this will be SR, then this will be RS. You can go either way. Same here, RR, SS, RS, SR, or you can say SS, RR, SR, or RS. Either way, out of these three, you can correlate. Jyoti is saying, all these years I never knew this chapter had these many concepts. Thank you for teaching us. Oh my God, Jyoti, really, I like your these appreciating words, and the thing which you are telling me from your bottom of heart. Really, I never skip even a single thing. I've taken two lectures for optical isomerism. I thought that the previous lecture I taught for 5.5 hours, that is totally, you can say, quarter to 6 hours, but something was missing. Then I asked the management, please to keep one more lecture, because optical isomerism has not been completed. So even if a single thing is missing, I feel pain. And if I'm going to tell you even a single thing extra, I never go for that. I always apply break, because whatever the thing is out of syllabus, I'm never going for that. And whatever is in your syllabus, I'm not going to skip even a single thing, kids, because future means a lot. When doctors, they are going to do even a single mistake, patients, they are not even to know what mistake has been done by that doctor, and they are not alive, kids. So same like that, what the doctors, they are not expected to do, same as teachers, we are just like that. You don't know what we are going to tell you, we are not going to tell you, but we know what we have to tell you. So I'm not going to teach you even a single extra word which is not required for a syllabus, and I'm not going to leave even a single word which is in your syllabus, whatever is required for the first rank. So notes I will share to the Telegram group. You know very well, just after the class, I always send the PDF of notes in the Telegram channel. You know very well. It's okay. And those who are not the part of that Telegram group, you can join HSPN Telegram group. HSPN Telegram group is also there, right? So you can join any Telegram group, and this question's answer you have to tell me in your comment section. I'll be waiting for your answer, and definitely I will reply the answer. What answer your answer is right or wrong, kids. We'll meet you in next session, right? So all the best, stay tuned, and just do proper revision. That is the most important thing. Try to find out your productive hours and do the best revision. For most of the students, that time must be the morning time. For others, it can be the night time, right? Bye. We'll meet you very soon in next session.